Hello, welcome to this breakout session on modernizing to a cloud data architecture. My name is Guido Oswald. I'm a solutions architect for Databricks based in Zurich, Switzerland. And after a short presentation from me to set the baseline, I will be joined by Matt Graves, the VP of Enterprise Data and Analytics at GCI Communications Corp, where he shares some of the learnings of the Hadoop to Databricks migration they went through. Should you have any questions during the presentation, feel free to ask them in the chat or Q&A section of this meeting platform. Let's have a quick look into the reasons to modernize from your legacy big data platform into the cloud, and then talk about the technical and business benefits we have seen at other customers. After looking at some of the ways we can help you control risk and cost of such a migration, Matt will tell us how all of this worked out at GCI Alaska. First question is probably the why. Why would someone looking at such a migration? Morgan Stanley has done some research on how our world will look past COVID, and they came back with the top 12 technology trends that will keep us busy in the next years. Clearly, the way we work and the way businesses work have changed dramatically in the last year. And this is not only in the retail sector, but across all verticals. Every one of us can see the change in our personal and professional lives. IoT has become a mainstream. Real-time streaming use cases are quickly increasing and everything gets mobile these days. All these changes we experience generate a massive data surge and therefore a lot of pressure on the legacy data and analytics backends that many times were not built for such scale and dynamic. Because of this increase in data and the changing requirements in terms of time to market, streaming and predictive or prescriptive rather than backward-looking reporting, we see the adoption of cloud-based platforms accelerating a lot currently. And the 100 billion pictures on the slide are actually only the increase compared to a pre-COVID estimate. So why don't the legacy architectures keep up? These silos that are pictured on the slide, data warehousing, data engineering, streaming, and machine learning, have evolved over time. Because these silos need to exchange data, the complexity has often grown to an amount that is very hard to manage. Also, the data governance and data quality have become an issue in such architectures. Many of the customers I am talking to have such a similar situation. There is a large amount of work going into building and operating such legacy platforms, which keeps the data teams from focusing on the important projects that they should be working on. This is also very true for the Hadoop environments that many of us have built in the past. So don't get me wrong here, Hadoop was a great technology and did great things in the past 10 years or so. But the legacy on-prem Hadoop installations cannot keep up anymore. The cost of running Hadoop cluster in the own data center is high, and it's getting higher. And this in times where we actually need to reduce costs. Many of the new use cases require real-time or near real-time data and reporting. And these use cases are often machine learning use cases, again, predicting something rather than reporting on past data. Because of these limitations and the complexity of legacy architectures, the data teams cannot get down to the high impact business opportunities and chances are missed. And ultimately, this will result in falling behind the competition. We probably all have experienced that it is extremely DevOps intensive to operate an on-prem Hadoop deployment due to the high complexity and the high failure rate. This results in low productivity because the engineers are busy keeping the system up and running instead of implementing the high-value use case I mentioned earlier. Also, Hadoop classes are pretty inelastic despite their theoretical possibility to scale. This is because they are sized for peak load, and it's usually a long process from the decision to expand the cluster to the hardware running and the software stack being deployed. I had a customer where this process took almost a year to complete. And this might be an extreme, but as you can imagine, in the cloud, we're talking about minutes to scale. And this usually happens at a much lower cost than on-premise hardware. When it comes to data science and AI, the Hadoop clusters can run some of the workloads, but usually you would need to add additional tool stacks left and right to support the development and deployment of such use cases. This usually creates new silos, limits collaboration, and therefore slows down innovation. So if we put together a list of requirements for a modern big data architecture based on the learnings of the past, this new platform should be cost-effective and easy scalable, easy to manage and work reliable with all kinds of data, and it should be able to process data and make predictions in real time. A recent Forrester economic impact study has found a stunning 417% ROI at companies migrating their legacy technologies to Databricks. They were benefiting from a higher productivity of their data teams and cost savings from switching off of their old infrastructure. Forrester also saw a 5% increase in revenue due to faster creation and optimization of ML models with Databricks. Before we look at how we solve these limitations and achieve such an ROI, let's quickly talk about Databricks as a company. Databricks provides a unified data analytics platform that allows data scientists, data engineers, business analysts, and machine learning engineers to work on a single platform, a single lakehouse, and dramatically accelerate information. We have a global presence with 5,000 customers and more than 450 partners. And you might know Databricks as the creator of popular open source projects like Apache Spark, Delta Lake, MLflow, Koalas, or Redash. We also coined the term lakehouse that is becoming quite popular recently, almost a new category, combining the data lakes and traditional data warehouses into a single platform. The Databricks Lakehouse platform combines the best of both worlds, the scalability, flexibility, and low cost of an open data lake, with all the benefits of a data warehouse like ACID transactions, upserts, time travel, indexing, and so on. The Databricks Lakehouse platform is built on standard cloud object stores like AWS S3, Azure Data Lake Storage, ADLS, or Google Cloud Storage, GCS. Unlike on-prem Hadoop, storage and compute are separated and can therefore scale independently. Storage will scale automatically. This is the magic that the cloud providers do. There is no more time spent on monitoring and replacing disks, optimizing the network topology, or expanding capacity by adding additional storage nodes that also add compute capacity, which might not always be needed. Scaling compute is almost as easy with Databricks. Users can work on shared clusters or work on isolated clusters on their own, depending on the requirements. We also support single node clusters, which are very cost efficient when working with small data sets, but still have a full Spark deployment available running in local mode. Databricks clusters support automatic scaling, and we provide a machine learning runtime with the most common libraries already included. And users can easily install libraries with pip or conda commands. The open source Delta Lake framework builds a layer on top of these storage and delivers all the features that we know from traditional data warehouses. With this additional layer, we can run multiple workloads on top that otherwise would need to copy data or work with a subset or less, and obviously delivering less optimal results. Delta Lake was also built from the beginning to support streaming data. This is a prerequisite for real-time applications and dashboards. With the collaboration features built into Databricks, all the teams are able to work on a single platform and on the same data at the same time. Doesn't matter if you're a data scientist exploring large data sets with Python, or if you're a SQL analyst creating real-time dashboards for customer support, or if you're a data engineer writing data pipelines in Scala, or if you're a machine learning engineer pushing a new machine learning model into production to better predict customer churn. Doesn't matter. The Databricks Lakehouse platform allows you to do all this at the lowest possible cost and minimum login. From a technology perspective, there are some low-hanging fruits for a Hadoop migration to the cloud. There are some others require a little more effort. As you would have guessed, Spark workloads transfer very easily to Databricks. If you are running still on Spark 2, I would advise you to lift this to Spark 3 and profiting from all the performance and other fixes we have done in the past. All of your Hive and Impala workloads can also be transferred with little effort to Databricks Lakehouse, to the Databricks Lakehouse platform. You can actually expect some substantial cost and performance benefits here. With Spark Structured Streaming, we have a perfect place for all your streaming workloads. Converting your legacy MapReduce code to Spark will obviously require some more effort, but again, the gains will be substantial. HBase workloads can sometimes move to Delta Lake if HBase was only used because of the limitation that Parquet has, for example, with updates. Sometimes these workloads are better housed in a cloud-native key-value store like DynamoDB or Cosmos DB. This depends on the use case, and we will look into this with you case by case. To speed up Hadoop to Databricks migrations, we also have automated many of the straightforward elements of such a migration project. The metadata of the Hive and Impala databases, for example, can be moved to the Databricks provided Hive metastore or a shared metastore from the cloud provider in an automated fashion. No need for manual intervention here. There is also some help replicating the security concept that is all the Sentry and Ranger policies to Databricks and the cloud. When you're using Uzi for on-prem orchestration, there are multiple options for you when you go to the cloud. Usually I see very happy faces when I tell my customers that there is no more Uzi in the cloud. One popular option is Airflow, but there are many other alternatives, and we will introduce multitask jobs very soon, which allow to execute multiple tasks in one job in serial or parallel in a Databricks job. So look out for the other talks on this multitask jobs here in the Data AI Summit. And then I see many of my customers using the native cloud tooling as well for orchestration, like Azure Data Factory or AWS Glue. Since Databricks has a comprehensive and open API, orchestration and automation can happen from pretty much everywhere, from pretty much every tool that is able to call a REST API. By automating on-premise to Hadoop Databricks migrations, we have seen quite some speed ups in the past. There are, of course, cost savings going alongside with this. This is a comparison of projects we did in the past. We have SI partners who are trained to help us with these automated migration, or Databricks professional services can also help reduce the migration time dramatically. Our fast partner ecosystem has many offerings that help speed up and de-risk Hadoop migrations. Some of them might already be in your toolset, or you can spot your favorite SI here. I should mention that Databricks is also available on the Google Cloud now, so you can choose to run the migrated workloads on all of the 3 major clouds. And since the Databricks platform is almost identical between the clouds, you can change your mind later on as well without starting the next migration project. I know that multi-cloud is not a big topic for many of us at the moment, but I expect this to change in the future. Another important aspect of the cloud migration is data movement. There's also a tool helping with this of almost all possible requirements. Usually it is unrealistic to move all the data into the cloud in one go or in a big bang migration. That is why it is helpful to have some synchronization between the on-prem and the cloud deployments during the phased migration. So to recap, we have talked about why it totally makes sense to migrate your legacy on-prem environment to the cloud and got a glimpse of the impact this can have. In terms of timing, I would say time is now. If you want to avoid falling behind the competition, you need to act quickly and realize the potential of a modern cloud-based data and AI platform like the Databricks Lakehouse platform. And we will stand by you. Databricks will help you migrating your workloads to the cloud as quickly and smoothly as possible. That is our promise. If you want to learn more, you can always go to our website for migrations and find some detailed white papers and some customer stories around these topics. And one of the customer stories you can hear right now from someone who has successfully done such a Hadoop migration to Databricks and the cloud. I'm honored to be joined now by Matt Graves, VP for Data and Analytics at GCI Alaska, to talk about his experience and learnings from this journey. Hey, welcome, Matt. Thank you for the time and for sharing your story today. And let's start maybe by having you introduce yourself and share a little bit about GCI Alaska.
Sounds great. Thank you very much, Guido. So my name is Matt Graves. I'm Vice President of Enterprise Data and Analytics at GCI. Started a little over a year ago in January of 2020, before the pandemic. It's been quite a year of learning and frankly, new experiences. A little bit about my background. For the past 20 years, I spent about eight years in Silicon Valley with internet startups. After that stage of my life, I got recruited to Microsoft, where I worked for the past 11 years, running a big data team. Then I started working at GCI after that, running their enterprise data and analytics team. Just a little bit about GCI. It's a quad play, so telecom, which means that it has mobile service to the state of Alaska. It has wireline access or internet access to the state of Alaska, provides cable TV to the state, and local and long distance service. So it's got quite an extensive network. I think we have, it seems like every imaginable technology. So we've got satellite, microwave, fiber, coax, 5G down to 2G. So it's a 40-year-old company in Alaska, and has grown organically with lots of technology, evolution along the way, which means my job in enterprise data analytics is there's lots of data to look at. That's the cool thing about the job, is that the type of problems that we're addressing and the tremendous amount of data that we have available to us to help support data-driven decisions. So thank you, Guido, for the opportunity to talk today, and it's nice to talk with you.
Yeah, nice to have you, Matt. So, what business challenges was GCI Alaska trying to solve, and what things did you wish you could do?
So we were blessed with a lot of data. We had an on-prem Hadoop stack, and it was about 60 terabytes of data, and we were constantly ingesting new network data regarding performance and call records and from all the different technologies. We were being asked questions about network optimization. You know, where do we build our next cell tower? Where is our network having troubles? What happens, kind of what if simulations on what if we upgrade this 3G to 4G or LTE, and the data needed to support that. So we had some challenges around just being an effective partner with our business in ingesting and making data available, and then doing analysis around the data. That was sort of problem one. But we're not just a network business. We have customers, and so the other sort of side to the problem is, what's our customer experience in the network? Yes, there's churn. Yes, there's new product adoption. But like, how are our customers actually using the network, and how is network performance, impacting user experience? We could do it in isolation for an individual customer, but if somebody said, well, how are you doing it for all your customers? Like, evaluate that. We just couldn't do it. And so it was an embarrassment of riches that we had the data, but we were paupers when it came to actually using that data to quickly and agilely solve those business problems. So that's sort of the high level of what things we wished we could do if only we had the capability. And the frustrating part is we had the data. So
yeah, I can feel you. I can feel you. Having worked for Cloudera many years and being in the Hadoop world for a long time, it's an awesome technology. But yeah, I had many customers with similar
facing similar problems. Can you describe some of the limitations of the old architecture that impacted GCI Alaska from either
Sure.
fully delivering its data strategy or expanding it?
Sure. I think that it's in some ways it's sort of apples and oranges, and I started and led that that drive to adopt Azure and the decision to adopt Databricks. The challenges that we had on our data engineering team were things like I was talking with a data engineer just this morning, frankly, and kind of refreshing my memory of the old world. And he was talking about how with NiFi, he would get 75 emails in the morning, kind of, with these like warnings and alerts. And he'd have to read through all of those emails, couldn't miss one. Then he would have to go into the logs and evaluate the logs to figure out where an error had happened. And generally speaking, it was like a group effort. So it was very frustrating. So that doesn't exist today. He doesn't want to go back to the old world, but now things like alerting, identification of error, figuring out where to resume the job or what error to correct makes his life much easier. There's sort of the elasticity and flexibility that you have in managing clusters and cluster sizes, spinning up clusters for right sizing for the right job. So that whole operationalization of our data management and things like that are easier. Those were problems in the past. With so many different types of data sources, schema changes of inbound data would change, and that would blow up our pipeline. And so sort of the ease and ability to manage schema changes is a differentiator. The data corrections, with inserts and deletes, upserts, things like that, which was possible in Hadoop, but just manually intensive and tedious, caused a constraint. And just to speak about the elasticity and flexibility, we sort of started our Hadoop clusters with sort of the right level. As we began opening up the data to business users who would access it with Alteryx and Tableau, we found that the compute function that had originally been calculated to be acceptable was being chewed up with lots of business users that were hungry for the data. And so our ability to expand the compute function so we could do more with the data was sort of had to be managed and caused limitations in our ability to serve the business. And we were always asked to do more. So that was a little bit of frustration for us and for our business users.
Yeah, absolutely. I remember also like this, a simple thing like updates. That was a tough thing to do, right? I mean, you had to put an HBase in front of it to be able to do updates, and it ended up in very complex architectures just to do updates. So I'm really happy that we have Delta Lake now, which eases up things a lot. So
makes a big difference.
Absolutely, yeah. And what was the compelling moment which led GCI Alaska to the aha that things had to be changed?
Well, I think that there was a realization, maybe even before I got there, that we needed to sort of reset and do something different in the future. I know that the company had sort of made some steps prior to my arrival, but we had not adopted AWS or Azure before my arrival. Having spent 11 years at Microsoft, running a big data team there, and my arrival at GCI, I guess I sort of brought that sort of driving experience to get it done. And so the company knew that we had to modernize our big data platform and harden it. There were many failures, week on week with pipeline failures and things like that for one reason or another. And we just had to have sort of the willpower, the drive and direction to get over that hurdle, to figure out what to do and how to do it and who to do it with, that sort of thing. So it was apparent, I think, when they hired me, that they knew they needed to do something. And I think it was business frustration, frankly, and the promise that we had a lot of data. We sort of knew what to do with it. We knew the business problems. We just weren't able to address those business problems, in a timely way. And we were able to make a compelling case for this is what we should do. We need to adopt Azure, and we need to adopt Databricks because of the tight integration, the capabilities that it brings. And we convinced enough people that we knew what we were doing that we got approval to do it. So that's sort of that.
Yeah, it sounds very familiar, to be honest. So can you share some insight why Databricks, and what was the migration process like?
So I had read a lot about Databricks, and I hadn't been a user before, but I understood sort of the benefits and the efficiencies that Databricks would bring. I'm not an expert on Hadoop. That's not my background or core competency. But I knew what Databricks could bring to us from an efficiency standpoint, operational efficiencies. I did a lot of research on Delta Lake and understood the benefits of Delta Lake. So it was more a matter of sort of conditioning the team on migration to the cloud, and the upskilling the team to understand that, what the capabilities were, and Databricks, by the way, did an excellent job in pre-sales, in evaluating our environment and helping us understand sizing and management and security and sort of all those questions that we needed to have answered, not just for my team, but for our security group, for our cloud platform team that manages our infrastructure. So it was getting involved very deeply with Microsoft in helping us with sort of the cloud adoption framework that they have, which is very good, and then getting deeply involved with Databricks, not being afraid to ask dumb questions and learn, and realize that it's okay to say I need help, I don't understand, I don't know, and learning. It's learning. It's just learning, and it's great.
I'm glad to hear that this worked like this, and we do our best to do this with many other customers as well. Can you provide a comparison between the old and the new architecture?
I'd be happy to. Yes, I actually have a couple of slides. As it turns out, I have a before with the Hadoop infrastructure, and essentially kind of reading left to right. We've got different data sources. So what data sources do we have? We've got all kinds of network services resources, telemetry from different systems, call record detail, detail around video, cable modem information on utilization, lots of capacity type things, alerting on many different aspects of our network. We have billing system data. We have lots of information on postpaid and prepaid and types of products that customers have. We also had some streaming data from some of our data sources and some data ingested from other types of cloud services. We had essentially, the typical NiFi, Scoop, and Uzi to schedule the orchestration of the ingestion and things like that. That's where the part of the 75 emails a day that went to one of our data ingestion engineers came from. We use the typical Cloudera Hadoop tools for normalizing, ingesting, unifying, and processing the data. For the consumption, though, we used Alteryx Tableau primarily for our business users or our data analytics team to pull data out for analysis and dashboarding and things like that. That is, I'm happy to say that we fully decommissioned all of our Hadoop hardware this year on January 31st. So none of that data, none of that hardware, about $1 million of hardware exists anymore. We're now fully on the cloud as of February 1st, operational of 2021. So we're a full, 4 months or so into it. Now we ingest using orchestration and processes housed in Azure Data Factory. And we use Event Hub for ingestion of some of our streaming services. We utilize Stream Analytics and of course, Azure Databricks to manage Spark clusters. And I think I've talked about some of the benefits of that recently. We're big believers in Delta Lake for some of the reasons I mentioned previously on schema changes. Something I didn't bring up before is Databricks sort of built-in capability to handle small files. That was a big problem for us before with Cloudera, and that problem solved with Databricks. So I assume everybody understands the small file problem. And when I ask, I don't know if you care to hear this, but when people ask me what is a distributed compute function, and this is not original to me, but this kind of illustrates the benefits of Spark and the small file problem. So if I gave you a packet of M&Ms and I said, count all the green M&Ms in the package, you'd pour the packet of M&Ms on the table and you'd say, there's 15 green M&Ms. I'd say, that's right. So that was easy, right? And you say, yeah, it's easy. Well, what if I gave you a dump truck full of M&Ms? If that was so easy, count the dump truck full of M&Ms. And you say, well, that's hard. And I said, well, what if you could recruit 10,000 of your best friends, keep track of all of the M&Ms, who's doing what, and then reassemble the results on the green M&Ms? So that sounds easier. But if I said, well, actually all the M&Ms in the truck are in small packets, and those small packets have to be sort of reassembled, and you have to deal with each of those small packets of M&Ms in the dump truck, you'd say, oh, that's more of a problem. That's harder. So the Spark clustering capability, handles large files well, does a great job. Small files are difficulty, and doesn't really allow that sort of distribution of compute function to be handled efficiently. Databricks has solved that problem for us, and we are very, very happy about that. In terms of, that was an aside, but hopefully that helps some of our listeners explain to non-technical users in a simple way that's easy to get their heads wrapped around. And we use MLflow, Delta Lake I mentioned. We store everything in ADLS, and then we still consume with Alteryx and Tableau, but we are moving more and more to Power BI and the Power Platform in leveraging and utilizing that data. So that's sort of the current architecture. the reasons why I think we've talked about the productivity gains that we've had in our uh, both our ingestion team and our analysts. I should say that also bring up, and I don't know if this is the right time to bring it up, but my team has essentially grown. And as we announced that we were utilizing Azure and Databricks, the data science team used to be separate from my data engineering team. And now with this more unified environment, and sort of unified set of tools, the data science team opted to join my team. So my team's grown, and I have another expansion with some data architecture folks that are all wildly competent, and sort of that aggregation and the closeness of these sort of cross-disciplinary teams and the collaboration they can achieve working more closely together. Even though they're separated due to the pandemic and everybody's on Microsoft Teams these days, having them in the same organization, and in fact, working on similar or the same business problems with their different disciplines has been sort of a major benefit. So the machine learning capabilities that are integrated with Databricks, the ease of integration with the Azure services, the elasticity has just made a big difference in our ability to execute. And sort of last, the sort of the improvements for our data science team, the interface is better. It's sort of like everything's better. Power and scalability to do machine learning problems, which now we do, almost continuously. And the integration with the Azure data platform has been a giant benefit for us from a security standpoint, from an operational standpoint, and a control standpoint. So hope that sort of addresses the question that you had.
Absolutely. And Matthew, we're talking about upskilling your team. Can you give us a little bit of advice on
Sure.
how to do this, or what your best practices are?
Well, there are practices that I've instituted, and I think they're best practices, or I'd like to think so. When I first started, I started in January, and this is an Alaska-based company. I'm based in Seattle, but I flew up to meet the team, and I was up there every week for about 6 weeks, just trying to get to know people and that sort of thing. My first all hands, this is before we made the migration to Azure. I said, by June 30th, I want every single person in my organization to have achieved the Azure Fundamentals certification. And so they're like, what? What is this? But, it was a good goal, and we were able to get every single person on my team to be Azure Fundamentals certified. Azure Fundamentals is not an advanced certification. It's sort of that ground level foundation. It was important to me for people to understand why we're migrating to Azure. If they talked about it at home or with a colleague at work, for each one of my team members to have a really good grasp of what Azure was and why we were doing it, the benefits that we would be able to achieve. And so, that was sort of the ground level. As the data science team joined and other data architects joined my team, that's sort of the entry point. You've got to do this first. Then there's lots of learning that more advanced learning that Microsoft and Databricks provides, from a professional development certification standpoint. And so what I asked each and every person on my team to do was sort of choose a professional development path and make progress, every quarter, earning badges or taking courses or getting certifications. And, I constantly want my team to continue to upscale their knowledge. It's been, I think, a good thing that the team knows what we're doing. They know why we're doing it. And even though we're learning every day, their collaborative learning, has been infectious, which is a good thing, and I love to see that. So it's sort of putting out the mandate, kind of scaring everybody at first, but then encouraging them to grow with their professional development certifications, and then be able to actually put those into use in a platform that we own and operate and run. I think is a great incentive, and it's been embraced by my team, and I'm grateful for that.
Absolutely. That's great. And let's switch gears a little bit and talk about the use cases and the benefits that are now unlocked.
Sure. It's interesting. We just went into production, full production, in the 1st of February, and the use cases are flying at us. I mean, it's all of a sudden I did a tech session with my team, some leaders from my team, on March 15th, and got a lot of interest from across GCI. There are marketing people, customer experience people, network services folks, product folks. It just about 100 of the more senior people at the company participated, and there's really a groundswell of interest in feeding us business cases. Let me describe a couple of those. Before I do, I would like to talk about, sort of make sure that we ground on what we're doing here. So I've got a slide that talks about automation of Databricks with Azure, the ingestion of network services data, pulling in the data, storing it in Azure Data Lake, then forecasting at scale, and I'll explain what we're talking about there, and then storing out those results and presenting it in Power BI. So with sort of network services optimization, a question can be, Alaska is a difficult terrain. It's a difficult area to achieve, mobile phone and wireline services, things like that. There's mountains and harsh environments and things like that. So in some of our smaller communities, we have earlier generation mobile phone capabilities, 2G, 2.5G. And as we think about what it takes to deliver services to those communities, it doesn't just take a cell tower, right? It takes the backhaul, back to our core to connect those phones with other phones. And if we have a remote community that we offer 2.5 or 2G services to, we likely use satellite to uplink and downlink the data communications. Satellite is slower than fiber, slower than microwave, and so when we want to upgrade a community from something an earlier generation to a later generation like LTE, we have to say, well, how are we going to backhaul? And how does that backhaul across maybe microwave towers, how does that affect the total capability, that total capacity, the bandwidth that microwave segment provides? And so we have to say, well, what do we expect the call volume to do? I'll go on to the next slide here. How do we project out the additional capacity as we go from 2 or 2.5G to LTE? What happens to the backhaul, and how much bandwidth additional is needed, and project out with simulations, peaks, and are there hospitals, and is there going to be video, and how is this really going to work? So the data science team, now has the data to be able to understand and look at analogous data sources, data points, and figure out how additional bandwidth utilization will be absorbed by the network, and where we might need to do upgrades in order to deliver the newer generation microwave connectivity to different communities. So, how would we do this without the data and without the tools to be able to analyze it? It's a sort of a crapshoot. So we don't want to do that. We want to do it with data, and we want to do it with understanding. Another use case is customer experience, and when we think about network alerts, network performance, outages, slowness, dropped calls, throughput. There's a lot to the network performance, but you have to link it to a customer, right? Because we're doing it for customers. We're not doing it because we like to provide network services. We're doing it to serve our customers and make sure that we provide high quality services. And it matters, right? It matters a lot. 911 emergency calls, run through the network, critical information to hospitals and healthcare clinics run through the network. And we really need to understand, as we have events or as we want to drive improvements, like who's affected, who's impacted. If we have an outage in a particular community, it'd be nice to know, who has an outage. And why do we care? We care about the customer, but we also care about our ability to serve the customer. So, if you have an outage, they might be, go to a landline, a wireless outage. They might go to a landline and call our call center, or they might chat, through a wireline internet access, with our call center. Well, if the call center doesn't know that there's an outage and who might be impacted, then, obviously call volumes increase, but we're not really, tooling our customer service representatives so that they can deal effectively with customers. And so that linkage of network performance and customer experience will help us with our dealing with customer calls, with marketing programs, with making sure that how we spend our marketing funds and where we go after new customers or try to go after our competitors, to get those customers to migrate over. It's important to know where we provide the best quality service and where we're most likely to win new customers and that sort of thing. The other types of use cases have to do with next best action. If a customer service rep or a retail store rep is talking with the customer, what should they be talking about, right? It matters where the customer lives. It matters what services the customer has. It matters what the experience of the customer is. So how do you figure out what to talk to the customer about and what's the most important, what's the most impactful, most meaningful to the customer? If they're on a 1 gig internet service and they've got a 7-year-old cable modem, well, you probably should talk to them about upgrading their cable modem because they're probably not getting the full benefit of the product that they're buying from us. So these next best actions, are initially rules-based, but the way that we're looking at this is using machine learning and getting feedback loops for, I offered this to the customer because it was supposed to be the next best action, but the customer rejected because, too expensive, not appropriate, whatever those reasons are, or they did accept it. And as we create a feedback loop for, what was the next best action recommended, did the frontline team member offer that particular best action to the customer? What was the customer's response? Did they want more information? Did they reject it? Did they accept it? That will feed into, we haven't finished developing this yet, but we'll feed into a machine learning model so we can fine tune those next best actions and get the biggest bang for our buck when we're actually in front of a customer, or online, talking with them about things that we think they should be doing with us.
Very interesting. Thanks Ned, for these insights. And having worked with a couple of telcos here in Switzerland and in Germany, it looks like many of the use cases are the same. The data is the same. The data volumes are the same. Though it's a lot of data we're dealing here with. And as a customer of these telcos, you actually see who's doing good, who's not, and you see actually how beneficial that can be also from a customer experience if you use this data efficiently. And all the examples you gave, right? If you do that efficiently, you feel much better as a customer. And you see there. Also, having said this, I think we are coming a long way in the past years, like using all this data, but there's still a way to go. And I think you're a little bit ahead of many other in your vertical that are needing to make this move from Hadoop into the cloud. So very interesting.
Absolutely.
So forward looking, how are you rethinking the role of such a lakehouse architecture can play in the future of the data and AI strategy at GCI Alaska?
So, it's an exciting future. I think the power of what we're doing is that we're able to connect the data. And so, I think in the past we looked at data in silos because that's what we could do, right? That's how we did things. And now, as we're looking at sort of the data and the integration and the sort of 1 + 1 = 3, the synergy of tying data together is very powerful. Being able to take alerting, for example, from some of our systems and being able to predict based on the messaging and the alerting what component of our network is failing. It sort of separates the signal from the noise and would allow us to, I believe, with machine learning, create an informed prediction model of maintenance or pending outage, capacity limitations. How do we address an outage in a more timely, more efficient manner? This is with data and compute power. And this isn't a negative about the company, but I see it as a target-rich environment. There's lots of opportunity. When we talk about placing inventory on our trucks for repairs, whether it's at a residential, whether it's at a customer's home, or whether it's a commercial business, or whether it's a cell tower, whatever, we don't know necessarily what equipment or what inventory is on what trucks. So when we assign truck rolls, to a home or to a repair, with the data and the power of data, and this isn't necessarily a data science model, but it's using data to say what's the best truck to roll, out to this, in the competency, of course, of the maintenance engineer. But who do we send, to this particular home to fix this, right? It matters. And truck rolls are expensive, especially in Alaska, which is huge, right? Biggest state in the union. So I think that it's a the future is really about deeper integration into business problems and being consultative, appreciating the pain that a particular part of the business might be going through, or introducing them to different ways of looking at a particular problem that's more data informed. Could be computer data science informed. It's an education and collaboration process, because some of the people in the business haven't known to come to us and have tried to solve problems with heuristics or whatever. And that's great, because that's how sort of things have been done in the past. But the future really is advancing the role of data in how we do everything, right? Serve the customer, expand to new communities, go after, new customers that our competitors have today. How can we act most effectively and most efficiently in performing our services? So that's what I see as our future, and it's a nice, has a nice long trajectory of business value. So I'm looking forward to that.
And I couldn't agree more, Matt, with this. I really think your guys are a little bit ahead of many others. So you already switched off your on-prem Hadoop. You're now completely into the cloud. You're leveraging all the benefits and realizing the value of the cloud and Databricks. So what advice would you give others out there that are on a similar journey to modernization?
So I think that it starts with establishing the culture of your team and education of your team, and it can be people adjacent to your team, but it's important to get the buy-in that this is the thing to do, and recognizing the opportunities for improvement and efficiencies. Um, it's collaboration in so if you and your team don't know why you're doing this, then you need to figure that out, because that's the foundation, and then you can start evangelizing about the benefits of this. I think that both Microsoft and Databricks did a very good job of helping us to understand sort of what to do first, second, and third. So, I always felt like I could reach out to Databricks and Microsoft and have a well-informed conversation with somebody that was very competent in what needed to be done, and that's a critical safety net. I think it's talking with the security organization early and often about what we're doing, and making sure that that they understand the architecture that you're moving to, and they might not be as informed, and so bring them along on your learning journey with you, right? Partner with them. Um, we heavily leveraged others in our business to establish our VNets and make sure that we understood exactly how to protect our environment, extend out our sort of our data center capabilities into the cloud, and how that would work. I was a little bit too aggressive in when I thought we would finish. So we started, we sort of made the decision that we were going to adopt Azure in around February. So we started having meetings, and I think focusing on what you need to do sort of first, second, and third. And there's really no other organization at GCI that's in Azure, so we were the first. We're the leaders, and in that cloud adoption framework that Microsoft has, there were a lot of learnings about, are we trying to build out our Azure environment? We used a hub and spoke model. Are we trying to do this in a way that serves every possible interest in the company, or are we going to try to serve enterprise data and analytics? And I was successful in saying we're going to do this for enterprise data and analytics, and that made a lot of the decisions easier. So I think focus is critically important to drive to an end goal that says this is what we want to do, this is how we want to do it, and recognizing that hub and spoke model, sort of different than Hadoop, you can change over time. So you're not there. There's one of the philosophies at Amazon is, if you make a decision, can the decision be undone, or can the decision be modified in the long run? Like how how impactful is this decision? And frankly, the decisions that you make should be well informed, but remember that this is a service, and the service can be modified and configured and changed. And if you have a capability that you need to include that you didn't think about in the beginning, you can include it later on. So you're not casting in concrete, exactly how things have to work for the next 5 years. It's morphable, it's changeable. So how you manage, how you tag, how you assign resources, how you create, functions in Azure and things like that. There is a lot of learning, but experiment, crawl, walk, run, and have confidence that you're doing the right thing.
Absolutely, I totally agree. And this is I think one of the great things in the cloud. You have the possibility to, I don't know, much quicker test something, fail, try something new. And if you stay on an open platform, open source, ideally open formats, you have the choice, right? You can try it with a different tool. If one tool doesn't work as you expected, go somewhere else. So I think this is very important, to stay on an open platform, open source, ideally, and build fast, quickly, make your learnings, and go further if you fail.
And again, don't be afraid to reach out to experts, in Databricks and Microsoft, because they are super responsive. And I'll just, one other thing, we accidentally deleted an important file, and we couldn't recover it on my own team, and we called Microsoft, and they were able to on their back end recover the file, and it was a sort of it was a mistake. It's just a mistake. And I guess the message here is that even though something doesn't seem like it's possible from a recovery standpoint or for an error correction standpoint, just make sure to reach out to your partners here, because they really are there to help, and they'll go the extra mile. And if it's possible, they'll do it. There were many times I know that my team was sort of thrashing on a problem, and I had to say, call Microsoft, call Databricks, let's get them on the phone, let's just do it right now, and they were there. So that doesn't mean you're outsourcing your thinking. It means you're reaching out for help, and sometimes that's hard to do, psychologically. But I would encourage you to do that and leverage the resources, because it's sort of faster time to value.
Absolutely. And this is what our job. So yeah, you already said it. Please, everybody out there, call us if you need help. Actually, before this recording, we did this recording. I was jumping off of a customer call where we did exactly a similar thing, right? So helping a customer in a last minute emergency. Yeah, this is our job. So don't hesitate to call us. And sometimes I find it magic what the cloud providers are doing in their, I mean, you can see what they're doing, how they do it, but I mean, recovering these files or delivering the performance, like the IO performance, when you add another instance and you get the same amount of IO capacity all the time. This is something that we all dreamed of back in the Hadoop days, right? So this is magic. Yeah, I get it. Hey, Matt, thank you so much for this talk and for your valuable insights. I think you helped a lot of others that are beginning their German journey now.
Let me say one other thing.
Of course.
So I just want to put in a plug here. We're recruiting for a manager, senior manager of cloud data engineering. So if there's anybody listening to this that is interested in joining the team and interviewing with us, please reach out to me directly. It's mgraves@gci.com, and I'd love to hear from you. So
absolutely. So hopefully there's many viewers on our Data and I Summit. So again, Matt, thank you so much. And thank you for everybody out there for watching this. And I wish you a nice rest of the summit and enjoy the rest of the sessions. Thanks, Matt. Thanks everybody out there.
Thank you. Bye-bye.
Bye.